Okay, so continuing to go over literal equations, this is just going to be review, so I'm going to go over every question on the notes. Your goal is to solve for the variable that they have in question. So if you remember to follow SADMAP as you're following these, of course there are special cases, then you should be able to solve. So number one, they want me to solve for t. T right here is being multiplied by I and R. And the inverse of multiplication is to divide. So I'm going to divide by what I'm trying to separate from t to both sides. And I don't know what p is. I don't know what I and R are. So it's just writing p divided by IR equals, the i's and r's cancel on the right side, equals t. Number two, this is one of those special cases where I cannot follow SADMAP, and here's the reason why. When I want to solve for W, there's L in the way by adding L, and there's multiplying by 2. Normally we would take care of that addition, but since the 2 is outside the parentheses, we are going to do the inverse of multiplying by 2 and divide by 2 to both sides. So A over 2 equals, that opens up the parentheses, so I have L plus 1 plus W. And to get W by itself, the opposite of positive L is to subtract L to both sides. And all I can do is write this, A over 2 minus L equals W. Number 3, to solve for x. So right now, x is subtracting 6 and multiplying by 5. SADMAP tells me that I would take care of the subtraction. And the inverse of subtraction is to add 6 to both sides. I don't know what y is, so all we can do is y plus 6 equals 5x, because the 6's cancel. To get x by itself, the inverse of multiplication is to divide by 5. Okay? And so y plus 6 divided by 5 equals x, because the 5's cancel. I could see this written where they separate it into two fractions. So I could see it as y over 5 plus 6 over 5 equals x. Both ways are correct. Number 4, to solve for y. Right now, y is being multiplied by -3 and then has a positive 2x on it. So the inverse, I would do SADMAP, so I'm going to take care of any subtraction and addition. The inverse of positive 2x is to subtract 2x to both sides. So the 2x's cancel, and I have -3y equals 8 minus 2x. And to take care of the inverse of multiplication is to divide by -3. So I have the -3's cancel, so I have y equals 8 minus 2x divided by -3. They could split this into two fractions, so you could see 8 over -3 plus 2x over 3, because -2 divided by -3 makes it positive. So you could see it written that way. Number 5, they want me to solve for x. Right now, x is being added to y and dividing 3. Normally, we would take care of addition, but since that dividing by 3 overtakes that addition, we're going to take care of division first. So the inverse of dividing by 3 is to multiply by 3 to both sides. The 3's cancel on the left side, so I have x plus y equals 5 times 3 is 15. Now to solve for x, I would need to take care of adding y. The inverse of adding y is to subtract by y. So x equals 15 minus y, because I don't know what y is. Number 6, to solve for b. Right now, b is being added to mx, or mx is being added to b, I guess. So the only operation here is addition, and the inverse of positive mx is to subtract mx from both sides. So over here I have y minus mx equals, the mx's cancel, equal b. So that one's a lot simpler than you think. Number 7, they want me to solve for y. Well, right now y is being multiplied by b, and it has a positive ax at the beginning. So SADMAP tells me to take care of this positive ax, and the inverse of positive ax is to subtract ax. That means the ax's cancel, and I have by equals c minus ax, because I can't combine those in any way. Now to get y by itself, we need to divide by b. So y equals, because the b's cancel, c minus ax divided by b. I could also see this written as two different fractions, so c over b minus ax over b. You could see it written that way. Number 8. Number 8, we're solving for b. Right now, b is adding c and multiplying by h. Normally, we would take care of the adding c, but because it's in parentheses, this h out here takes priority. So the inverse of multiplying by h is to divide by h. A over h equals, the h's cancel, and I have b plus c. It opens up that parentheses. And to solve for b, the inverse of adding c is to subtract c. So a over h minus c equals b, and the c's cancel. Okay, as we continue through this, number 9, they want me to solve for L. So right now, L is being multiplied by W and H. So the inverse of multiplication is to divide, and I'm going to divide by what I'm trying to separate from L. So I'm trying to separate the W and H at the same time. So I'm going to divide both sides by WH. Over here, V divided by WH equals, the WH's cancel, equals L. Number 10. All right, this one we haven't seen before, so let's see it. To solve for R, okay? So right now, R is being multiplied by 4, and it's being squared, okay? So first, we want to take care of multiplication because SADMEP tells me I take care of multiplication before I can take care of the exponent. So the inverse of multiplication is to divide by 4. So I have A over 4 equals, 4's cancel, and I have R squared. Okay, we're not done because they want me to solve for R, not R squared. So the inverse of squaring something is to take the square root. But what I do to one side, I do to the other. So my answer is square root of A over 4 equals R. The square root of R squared is just R. You could see this where they take the square root of 4 because the square root of 4 is 2. So you could see it written like that in simpler terms. Number 11, they want me to solve for h. Right now, h is being multiplied by pi r squared. Well, the inverse of multiplication is to divide. And again, I'm going to divide by what I'm trying to separate from h. So I'm going to divide by pi r squared, the whole thing. Divide by pi r squared. So v over pi r squared equals, the pi r squareds cancel, and I have h. Number 12, they want me to solve for x. Right now, x is being multiplied by 7 and subtracting y. SADMEP tells me I take care of subtraction, so I'm going to do the inverse of subtraction, which is to add y. I have 7x equals 14 plus y. To get x by itself, the inverse of multiplication is to divide by 7. I'm going to divide the whole thing by 7. So x equals, so it could be written as 14 plus y over 7, or they could split this into 2 fractions. So 14 over 7 simplifies to 2, but y over 7 does not. So it could be written as this as well. Number 13, they want me to solve for y. Right now, y is being added to x and dividing 2. Normally, we would take care of that addition, but since the division takes priority, the inverse of dividing by 2 is to multiply by 2. So I have 2a equals, multiplying by 2 takes care of the 2's on the right side, and I have x plus y. To get y by itself, what's the opposite of positive x? Negative x. So my answer is 2a minus x equals y. Number 14, they want me to solve for I. Okay, so this one's a little tricky, so I'm going to put a little star by it. To solve for I here, you're like, Miss, I see I is being divided, but how do I move the e? A lot of people think I'm going to multiply by e. That's wrong, okay? So this step is going to seem really silly and idiotic, but let me explain it. First, I have to move the I. The inverse of dividing by I is to multiply by I. And you're like, Miss, but I'm trying to solve for I. Let me keep going. So I times R equals, the i's cancel, equals e. Now, we were not looking to solve for e. But now, if I look over here, to solve for I would divide by R. So now that I have I by itself, my answer is E divide by R. So it's kind of silly, but you have to follow that step whenever the I is in the denominator. Number 15, to solve for Z. Okay, to solve for Z, Z is being multiplied by Y and dividing by 6. So first we take care of that division according to SADMEP. So I'm going to multiply by 6 because the inverse of division is multiplication. 6 times x is 6x. The 6's cancel and I have YZ. To get z by itself, the inverse of multiplication is to divide by y. So I have 6x divided by y equals z. Number 16, to solve for L, okay? So to solve for L, this is a lot like number 14. You look at it and L is in the denominator. Normally we would multiply by r, but because r is in the numerator, we can't multiply. So in order to do this, we need to multiply by 2L, so that way we can move the denominator. So we have 2LA equals R, because the 2L's cancel. Now to get L by itself, L is being multiplied by 2 and A, and the inverse of multiplication is to divide by what I'm trying to separate from L. So I'm going to divide by 2A. So the 2A's cancel, and I have L equals R over 2A.